So welcome to part 2 of electric charges and fields. In the previous class we have discussed about what is meant by electric charge, and we have discussed about charging by friction and charging by induction. Today we are going to discuss properties of charges, and we are going to discuss a fundamental law in electrostatics that is called as Coulombs law. First, properties of electric charges. First property is the additivity of charges. What it means is the total charge on a body will be equal to the algebraic sum of all the charges that it is containing. For example, if an object has got 5 coulomb of positive charge and 3 coulombs of negative charge, the total charge will be 5 minus 3 equal to 2, that is plus 2 coulomb of positive charge. Or vice versa, let us say we are having minus 5 coulomb of negative charge and 3 coulombs of positive charge. So it will be minus 5 plus 3, that is minus 2. So it will have a negative charge equal to minus 2 coulombs. That is called as additivity of charges. So any object which contains a number of charges, the total charge will be equal to the algebraic sum. Next is called as conservation of charges. The total charge of an isolated system is always conserved. So we cannot, it is similar to the conservation of energy. We cannot create energy, we cannot destroy energy. Similarly, we cannot create any charges, we cannot destroy any charges. The total charge of a system always remains constant. So let us say we have done charging by friction. If one object has lost 5 electrons, the other object would have gained the 5 electrons. So if one object loses some amount of charge, similar amount of charge is added to some other object. So charges are never destroyed, charges are always conserved. This is called as conservation of charges. And third very important property, that is called as quantization of charges. The total charge of any object will always be an integral multiple of charge of an electron or proton. So we have discussed charge of an electron or proton is 1.6 into 10 to the power minus 19 coulombs. So if any object has got any number of any amount of charge, it will always be an integral multiple. For example, you can have a charge of 1.6 into 10 to the power minus 19 coulombs, or you can have twice that charge, that is 3.2 into 10 to the power minus 19 coulombs. There is no in between. Correct? That is called as quantization of charges. You cannot have, absolutely not allowed, absolutely not possible to have a charge of, let us say, 2.1 into 10 to the power minus 19 coulombs. You cannot create that kind of charge. It always has to be integral multiples of charge of one electron, which is 1.6 into 10 to the power minus 19 coulombs. So always, if the question is asked that if X amount of charges possible, if an object can have X amount of charge, you have to divide it by charge of an electron. If the answer is an integral multiple, only then you can say that kind of charge is possible. So this is properties of electric charges. Now next, as I told you, we are going to discuss a very fundamental rule in electrostatics, that is called as the Coulombs law of electrostatics. So let us first see what is the statement. Coulombs law says, if you have got 2 point charges, the force of attraction or repulsion between the two charges will be directly proportional to the product of their magnitudes and inversely proportional to the square of distance between them. I think this statement will remind you of the Newton's universal law of gravitation. It is very much similar to that, only thing we are replacing the masses of objects by the magnitude of their charges. So let us see what it means. You take 2 point charges, they are at some distance from each other. They are going to exert forces. Now that force can be attractive or it can be repulsive. So let us say we are having 2 point charges, they will exert some force on each other. Coulomb's law says that force will be directly proportional to product of their masses, product of their charges. So if one object is having 1 point charges Q1, the other one is having charge Q2, the force will be directly proportional to Q1 multiplied by Q2, that is product of the magnitude of their charges, and inversely proportional to the square of distance between them. Correct? So what you can understand is, if the magnitude between the two charges is very much higher, the force will be higher. Conversely, if the distance between them is higher, force will be lower. Correct? So if the charges are very close to each other, the force is going to be higher. If you move the charges away from each other, the force is going to be lower. Correct? So that is Coulombs law of electrostatics, a very fundamental rule. Anything that we study in electrostatics, when we study about electric fields, when we study about electrostatic potential, we always come back to the Coulombs law of electrostatics, as I said, which is a very fundamental rule. So this is Coulombs law of electrostatics. Imagine we have two charges, Q1 and Q2. Let us say they are at a distance of r from each other. Coulombs law will say that the force that is exerted by the two charges on each other, F, is directly proportional to Q1 multiplied by Q2 and inversely proportional to square of the distance, that is r square. So we get F proportional to Q1 Q2 by r square. To remove the sign of proportionality, we will add a constant. So we will get F is equal to K Q1 Q2 by r square. K is our constant. We have found that K is equal to 1 upon 4 pi epsilon naught, and the numerical value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. Epsilon naught is a quantity which is called as permittivity of free space. It is a constant that helps us to know how far the electric field is going to be propagated. So this is Coulomb's law of electrostatics.